Hello viewers, welcome back to our YouTube channel, and today we want to continue with our series of quantitative techniques. In the previous video we spoke about the arithmetic mean, and we looked at both the ungrouped data and then the grouped frequency distribution. And of course we promised that we are going to look at the median. So we want to look at the median. Let's look at the median. As one of the second measure of central tendency or measure of location. Of course, whenever we are talking about each of these measures of central tendency, you should be asking yourself, why do we call it a measure of central tendency or a measure of location? In other words, how is this value going to be a central value or a central point? So the median looks at the middle value. Median is the middle value when all values in a distribution are arranged in order of size. In other words, we arrange these data values based on their magnitude or the size. So if the value is going to be an odd, if the number of values is going to be an odd, we get the median, or the median becomes exactly that number that is going to be in the middle term. But when the number of the values is even, then the median becomes the average of the two middle terms. So there are two things whenever you are trying to find the median. If the number of values is an odd number, if the number of values, if you count the numbers and they are in odd, then you know that the value that we are going to get as the median will be the exact value of the middle term, so it will be that very number that will be in the middle. But if you find that the data set, or the number of values are even, in other words, once you count these number of values that have been given to you and you find that they represent even numbers, Even numbers we know those are 2, 4, 6, 8, 10, 12. Those are the even numbers. Odd numbers we know it is 1, 3, 5, 7, 9, 11, and so on. So the moment you count and you find these odd, then you know the median is going to be in the middle. It's going to be that exact number that will be in the middle. But if you find that the data set that you are dealing with, or the number of observations or values are even, then the median is going to be the average of the two middle terms or middle values that we have in the data set. So if the number is even, then the median is the average of the two middle terms or middle values. So when you're looking at the median represents the number that is going to be in the middle of the distribution. So whenever we are talking about the median, just know we are trying to look at halfway point in the data set. We look at half of the data set, and of course the median of that data set is going to be that value that is going to lie in the middle of the data set or in the middle of the data, as long as that data or that data set has been ordered. Once the data is ordered, we call it, the moment we arrange the data into either ascending or descending, we call that a data array. That's when the data set has been arranged in a certain order. Now, of course, we know that before you find the halfway point, before you find this point, the data set must be arranged in a given order. And when we arrange the data set, we said it is called a data array. And of course, the median either will be a specific value that is in the data set, or that value can fall between two, two data values. So if the data set is odd, we find that the median is going to be that middle data entry. So if the data set is going to be having even numbers of entries, then the median will be the mean of the two middle data entries. So if you look at the median, median is a positional average. We call it a positional average. Median is a positional average. We call it a positional average because it is that value that lies exactly in the middle of the data set after you have arranged or you have placed that data set in an order, or what we call an array. So we want to understand, of course, we know we have seen how to get the median for individual values, but we need to know starting from the individual observations, but to also look at both the grouped and then the ungrouped frequency distributions. So when you are computing the median of a data array, we arrange the data set in an order. And we said that if they don't specify that they want you to arrange the data set in such an order, we always go by the ascending order. We always use the ascending. We arrange data values according to their sizes, but we start from the smallest. But of course, we shall see that when we are dealing with maybe data set that is going to be a little bit more, we can involve in a formula. But if you are looking at something small, we can use just arrange the data set, then we look at what is in the middle. So let's look at an example before we start introducing in the formulas. Let's say the weights of 7 police recruits are, we have 80, we have 86, we have 91, we have 101, 109, 120, and of course the last one is 106 kgs or kilograms, full stop. They're asking us to find the median. They want us to find the median. So we said the first step is for us to arrange. Let's get a solution. We said our first step is to arrange step number 1 is to arrange the data in order. So that's what we should start with. We start with the smallest and then we end with the largest. So we have 80, comma, we have 86, that's the next one, comma, 91, comma, 101, comma, we have 106, and then 109. Finally, we have the 120. Of course, you can see that this data set is arranged let me maintain the color here. So 106, then we have the 109, and then finally we have 120. So if you count these values, you can see 1, 2, 3, 4, 5, 6, 7. There are 7, meaning that's an odd number. It's an odd number, so implying that what is going to be in the middle will be our middle value. So of course we used to do median, whereby you cancel this, then you cancel this, 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 and what is left in the middle becomes our mode. So our mode is 101. That is our model value. Now we are going to look at the method. We are going to look at the method. If we use a formula, how can we conclude? So here we have looked at the median is actually, the median is 101 kgs, because remember these were kilograms. So the middle value is 110 and it's our median. Now if we are looking at, or if we are using a formula to compute the middle value, this is the formula that we always use for ungrouped data set. We get the n plus 1 divided by 2, and this n is actually the total number of observations or values, then plus 1 if they are odd. So this is specific to odd if the total here is an odd. Just like the way we've seen the other side, we had the numbers, there were 7. So it would be, if we are to use the formula, it would be 7 plus 1 divided by 2. This means it's 8 divided by 2, which is 4th. This gives you the position, 4th number. So once you use the formula, it gives you the position where the mode lies. It gives you the position where the mode lies. So we have seen that we have got 4th. We have got a 4. So we are going to count 4 numbers. The 4th number will be our mode. So let's look at the data set and we try to count and see. Of course, it is the same procedure. You first arrange the data and then you count. You arrange the data. That's a procedure. So if you look at the data set that we have and you count. This is 1, you count the arranged value. This is 1, 2, 3, 4. And they told us the fourth value is our mode, which is 110, 101 kgs. So either way, you are good to go, as long as they have given you individual data set, and at the same time they have not given you classes, or they have not given to you items that have frequencies. So I want us to look at a simulation that looks at the data set when it is even. So let's look at the data set that is even. Let's take an example. Let's say the number of pages in 10 textbooks textbooks were recorded as follows. So let's write the numbers: 414, 398, 402, 399, 400, 405, 395, 401, 412, then 407, full stop. Find the median. So we want to get the median. And of course, we said the first step is for us to arrange the values, in order of size or the magnitude. We look at their size. Start with the smallest and then we end with the largest. So we arrange the data set. Of course, we start with 395. There are two 395. Then 398. Then 399. 400. 402. 405. 407. 412. Finally, we had 414. So these are the values that we had. So if you start cancelling these values, you cancel one side, one on the left and one on the right. This and this, this and this, this and this, this and this. You will see that these values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 values. So you will see that the numbers that have remained, they are in the middle, these two values. So we get the mean of those two values that are in the middle. So it is 400 plus 402 divided by 2. That will give you your median. So once you add those two values and then you divide by 2, you'll get 401. Because this is going to give you 802 divided by 2, it gives you 401. Remember, these were pages, so you write it as pages. 401 pages. That will be your median. Now if you want to use the formula, if you want to use a formula for even values, it's n over 2. This is even. We get n over 2, and we counted there were these values were 10. Divide by 2, that gives you 5. The fifth number. The fifth number. So if you want to count the fifth number, you will see that this is 1, 2, 3, 4, 5. It gives you 400. But if you also try to count 1, 2, 3, 4, and 5, you will see that this side are 5 and this side are 5. It means the value that those two values, the one that are going to be in the middle, they are the ones that we are going to be taking. So we take those values, they are the ones that are going to help us get the median. So once you have gotten the fifth number, then you count those values and then you sum those two values, because you see the fifth number is giving you 400, and even when you count from the other side, from both sides, it gives you that fifth number. That means that's the number that is in the middle. So that's all that we can talk about as far as the median for data set that is not having frequencies, or that is not within a distribution. Now I want to look at the median from the point of view where we have frequency distributions. So we want to get the median of ungrouped frequency distribution. Of course, for you to be able to compute the median of ungrouped frequency distribution, in other words, we have the discrete values, but these values are so many and they repeat themselves. So what is key here for you to calculate the median is for you to be able to compute the cumulative frequency distribution. You need to be able to compute the cumulative frequency distribution. So that's why when we were first talking about some of the things, we made sure that we really get to understand the different steps, how to draw those cumulative frequency distribution tables. Those are the things that we went through in our first videos. So maybe we can just have small steps just to emphasize, steps to be followed. Steps to be followed so that we can have the cumulative frequency distribution table. Of course, we know that we write these values in columns. We write the values in the columns, the values of the different variable, or the values of the variable that has been given to us. Then we write it against their respective frequencies, and of course we go ahead to compute what we call the the cumulative frequency column. We compute those values and then we locate the middle data set using our n items. So the first step is for us to find the less than cumulative frequencies. You find the less than cumulative frequencies. Then the second step is for us to find the position of the median value Then the third step is for us to find the cumulative frequency. Find the cumulative frequency equal to the above position number 3, or in 3 above. Equal to the above position, or it could also be just the greater than position. It can be above or it can be below. Then the fourth step is for us to locate the corresponding value. Of course, the value corresponding to step 3 above is the median. So we will understand some of these things when we are doing a practical simulation. So let's pick maybe a small example, then we'll be able to go through what is needed so that we can be able to move. So let's have a example. The table below shows the marks obtained, by students in Chuti paper. Full stop. Find the median. So we have the marks, and then we have the frequency. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So they want us to find the mean. Of course, for this one, we get the let's first put in the frequency. Frequency here is 25. Those who scored 0. This is 46. This is 63. This is 87. This is 124. This is 203. This is 117. This is 100. This is 90. This is 55. And this is, the last one is 10. So we want to get the median. Of course, we can just add in here. Just a column for cumulative frequency. We just add a figure for cumulative frequency. So how do we get the cumulative frequency? We said we just get the frequency, and then the first one, we maintain it. It's 25. Then 25 plus plus 46. We add this first one to this one. This will give you 71. 71 plus 63, it gives you 134. 134 plus 87, that gives you 221. 221 plus 124, that gives you 345. 345 plus 203, it gives you 548. Then 548 plus 117, that gives you 665. 665 plus 100, that gives you 765. Then 765 plus 90, it gives you 855. Then plus 55, it gives you 910. And then plus 10, it gives you 920. 920. So the 920 is our last, meaning our total frequency is actually equaling to 920. Now, one thing that I want to clarify is the fact that if you look at this data set, the marks that we have, if you count the data values that were given to us, they are 10. They 10. This is 1, 2, 3, 4, 5, 6, 7. They are 11. They are 11 because even 0 is inclusive. 0 is inclusive. So they are 11. Most of the times, when you're dealing with ungrouped data, we always use, most of the times, we always use this n plus 1. We always use that kind of data set of saying that we take n plus 1 over 2. So we've gotten our summation f, which is the n, as 920. So if we divide this by 2, it will give us 455. Now you see, you may not have a value that is exactly 500 and what? That's 455. But you will see that if I try to look at this data set and I try to locate this cumulative frequency, because what we do, we compute these values. After computing the cumulative frequency, we get our n over 2. And now, this n over 2 has given us 455, but we don't have that value there. So we try to locate it and see a value that is maybe less or greater. Then we know that in between there, that's where that value is. So but if you try to, when you try to use this one, let me get for you the difference, is that this n plus 1 divided by 2, it will get you the 900. Our n is 920 plus 1. Then you divide this by 2. They are all of these are just giving you positions. They are not the real values that we want, but they give you the position. So this says it's going to be around 460.5 fifth number. So these are just positions. Maybe this one we divided it wrongly, divided by 2. This is 460. Sorry, this is 460. So you are seeing that this 460, if you try to locate that value, within here, because these two methods of getting n, whether you use n over 2 or use n plus 1 over 2, and you try to locate these values, you'll find that it's around here, within this value. Its equivalent in the cumulative frequency is 548. So this 548, it corresponds to which value? You look at the data set and check to see where that value falls. So the picture I'm trying to make for you is that this is just like an estimation, because we are not getting the exact values, but we are getting the estimate. That's why for you to use this n over 2 and n plus 1 over, to use it when the data set doesn't have frequencies. But if it has frequencies, the figure you are going to get will just give you an estimate of where the value lies. So the implication is that this value you're seeing here, it says now our median is going to be 5. Reason, because this 548 is the one that is close to this. Because when we divided, we've gotten 460. So the value is in between this and this, within that range. That's where that value is. But because we want to be specific, we pick a value that is going to be greater We can't pick the value that is less, because once you pick a value that is less, it means you have excluded some of the values. Because if you see the difference that is between 400 and 460 and this smaller one, which is 345, you are seeing that really the difference is so much. So that's why we pick a greater value. And that's the very reason as why we find what we call the less than cumulative frequency from the other fact that I told you when we are drawing the ogive. I told you when you are drawing the ogive, most of the times we use the less than. That is the reason, because we always want to estimate the value that is greater. So for this, it is just for you to understand, but as you are computing some of these values, that's why I've given to you a question that has frequencies that are actually higher. Because if it was maybe just 10, it would be very easy for you to estimate, because you will be seeing maybe if our n over 2 was, let's say, 5, it would be very easy for you to take a 6. But I wanted to give you something that is going to give you a very bigger margin. So that's what we can talk about as far as the median for ungrouped data is concerned. One thing that I want us to focus on is the fact that for you to get the median, as long as there are frequencies, you have to get cumulative frequency distribution table. You draw a cumulative frequency distribution. That is very important. It's the same way when you draw your ogive and then they tell you to estimate the mean. If you are to use the graph, you would have plotted this. You would have looked for this 460 on the graph, because at least on the graph you can get an exact value, somehow close. So that's all for the ungrouped. So I want us to look at the median for grouped. Median of a continuous, the other one was a discrete, of a continuous in bracket we can say grouped frequency distribution. Frequency distribution. So of course we have looked at the same way we have done that is the same way we are going to do this. The only difference or the only additional part that we are going to have is the fact that these are actually classes, and we shall need what we call the class boundaries. So these may actually be the additional items, just the class boundary and then the values are going to be given as classes. That's the only difference. So sometimes you need to estimate the median from the frequency distribution. Of course, we do this by first of all determining the interval. We determine which interval contains the median, and then we determine the proportion of the interval needed to get up to a halfway point that we talked about. Of course, most of the times they call this interpolated mean or median, or what you call the estimated mean, because most of what we are going to be doing, we use formulas, and when you try to look at the reality of it, you find that these are actually normal estimates, but they are not giving the exact values. So in this, we've said what is going to be very different is the fact that we are going to look at the median class. We need to identify the median class. Then two, we get the class boundaries, and then the cumulative frequency. Once we know these values, then we can be able to compute the median of a group T frequency distribution. Of course, we are now in the parts of some of the examinable questions. That's why we have to understand some of these things. So let's look at the formula for computing the median from a group T. So the formula for the median of course, this one LM plus, we open bracket, n over 2 minus cumulative frequency before over Fm, then times I. So these values, different textbooks will use different values or different letters, but what is very important is for you to understand what they are. Let me start with LM. LM represents the lower class boundary of the median class, the lower class boundary of the median class. That is our LM. We know N N is our total frequency. Then CFB, that is cumulative frequency before. Cumulative frequency before. Then our I is actually the class interval. Class interval. Sometimes they call it class width. We explained some of these terminologies earlier. And FM is the frequency of the median class. FM represents the frequency of the median class, this one down here. So that's the formula that we use. Of course, we are going to understand this question maybe when we have taken a practical question, and then we can be able to get an understanding But one thing I want you to understand is that it's always hard for us to find the median the median if at all we have grouped frequency distributions. Because if we have grouped frequency distributions, it means we don't have the individual values that we can arrange in either ascending or descending order. So the values that we have are just the approximate values of the median, or the appropriate values for the median that can be obtained from either the interpolated values or formulas, or using the cumulative frequency curve, or what we call the ogive. So we are going to have maybe one question that will have both the that will ask us to use the formula, then maybe later on you'll do on your own, you do the same number when you're using the cumulative frequency curve to see whether you are going to get the exact similar values that the ones that we have obtained. So example, says 2 steel bars They are saying 200. Steel bars produced by ST rolling mill were measured and the results are summarized, in the following table. So we have the length in meters, then we have the frequency. The first one is 20 to 22, 23 to 25, 26 to 28, 29 to 31, 32 to 34, and finally we have 35 to 37. Then the frequencies, they told us they were 200. So the total frequency will be 200. So this is 8, 34, 82, 50, 14, and then 12. So we look at the required. So the required says part A, by calculation estimate the median. Then part B says construct a cumulative frequency curve, what you call the OGIF, and use it to estimate the median. I explained to you how you can use the other solution. So I explained to you how you can use the OGIF to estimate the median. So if you don't know how to draw the OGIF, just go to our previous video lecture, then you go through it, be able to do the median from the OGIF after understanding how to draw it. So the steps: we get the cumulative frequency, then we get the class boundary, and then we substitute in the formula. The formula is always the easiest way, because you'll be getting, of course, most of the times you may fail some of these numbers, not because you don't know, but because maybe you have done some arithmetic errors. Because just imagine if you just miss by just one. If instead of adding 37, you added 36, the whole thing will be wrong. So even when things are very easy, you be careful when you are dialing these numbers on the calculator. So let's start having these numbers. Start with our length. Length in meters, because we had 20 to 22, then 23 to 25, 26 to 28, then 29 to 31, and 32 to 34, then 35 to 37. From this first information, what you have to get is the class interval, because you know the formula. We have now the frequency. I'm just going to call it F. So this was 8, this is 34, this is 82, this is 50, this is 14, This is 12. So we get our total frequency. This is summation F, and they told us they are 200. So we can pick it from the cumulative frequency. So from here we can easily know this is 8. Of course, 8 plus 34, it is 42. 42 plus 82, that is 124. 124 plus 50, that is 174. 174 plus 14, that is 188. And 188 plus 12 gives you 200. So indeed our total frequency is 200. So we get now the class boundary. We get the class boundary because these are inclusive classes. So we said to get the class boundary, we take off 0.5 from the upper limit, and then we add a 0.5 on the other upper limit. So on the lower limit, which is 20 minus 0.5, it gives us a 19.5. So remember what I told you, you can start with the upper limit. This is 22.5. Then of course now you can get the class interval. The class interval, we always get it from here. We can get either 23 minus 20, that gives you 3 from here, this one and this one, or this one and this one, or you can use 25 minus 22, that gives you 3. So I just come here on the 22.5, I just add 3. If the class intervals are the same, I just add 3. It will give me a 25.5. This one will, when I add 3, it will be 28.5. On this one, it will be 31.5. Then this one, it will be 34.5. And lastly, it will be 37.5. And I told you, if you want to get these ones, you just take this one to this side. So this will be 22.5. 22.5, this is 25.5, this is 28.5, this is 31.5, this is 34.5. Now on this other one, you just get this 22.5 minus 3, which is the class interval. It will give you 19.5. So whatever side you take, 19.5. Now what we are going to do is to get our median class. How do we get our median class? We just take n over 2. What is n over 2? It is 200. Our n divided by 2, that gives you 100. So it is 100th number. We check where is this 100 going to lie. the 100 lies in this area here. You circle that. Maybe you use a pencil and then you circle it like that, because that's where we have the 100. We don't have 100 specific, but we have a value that is above 100, which is 124. So from we have identified the model class, then you come down here, you start the computation. So you can see from here that our lower class boundary is this. This is our lower class boundary, So we compute our summation f over 2 or n over 2, which was 200 divided by 2. That gave us 100th number. So we checked this and we have gotten the model class, the median class as 26 to 28. So we substitute into our formula. Because the formula the median, we said using the formula we said is LM plus open bracket n over 2 minus cumulative frequency before over the frequency of the median class times our class interval. So the lower class boundary, we had it as 25.5 plus, this is the lower class boundary of the median class. Then n over 2, n was 200 divided by 2 minus cumulative frequency before, that is the cumulative frequency before the median class, which was 42. Then we divide by the frequency of the median class, and the frequency of the median class was 82 times our class interval. This was 3. Of course, once you substitute that, you will be getting 26.5. And these are meters. So that's the median class. Now, if you want to get to the ogive, of course, you are going to draw you put the cumulative frequency on the vertical, then you put the class boundaries on your horizontal, and then you'll be able to plot. So that's all that we can talk about as far as the median is concerned. We want to look at the mean, the mode in the next video, then we'll be able to finalize, because we say these 3 are the basic measures of central tendency or measures of location. Then the other weighted, of course, we shall also look at the weighted mean or the weighted average. Then we also look at the harmonic, the geometric, and then the combined mean if time allows. So thank you for watching. Endeavor to subscribe, share to others, and also let us know in the comment section what you think of the video that we have just done. If you have any question or query about what we have just done or what you have not understood, can put it in the comment section. We shall be able to respond to you and we iron that out.